Hello everyone and welcome back to our session on flavonoids. We were learning a class of beautiful natural pigments called as flavonoids. Flavonoids naturally are yellow in color, but there are certain classes called as anthocyanins as we previously saw, and because of their charged nature they have different colors. So you can see different flowers herein, and these are all anthocyanin containing, and nature converts flavonoids into anthocyanins. Plants store them carefully in their flower petals and then they exhibit the beauty. Now we will dwell little bit more in this week in some flavonoid containing drugs. To start with, in this session we will deal with three drugs. The first one is a orange peel, the second one is buckwheat, and the third one is our interesting fruit strawberry. So let's see. The first drug what you are dealing here is orange peel. Now you might be wondering, what we consume in our day-to-day basis is actually an orange pulp. But what is of more important here is the orange peel. Surprisingly, orange peel has much more medicinal value than your orange pulp, and here's the reason why. So to start with, oranges or citrus fruits are abundant. There are numerous species of citrus fruits ranging from bergamot to your Buddha's finger to your lime, kefir. You might come across different Malta. You might come across different orange species in market also nowadays. So let's take one simple example of an orange peel containing drug, that is the common fruit that you consume, that is your Citrus aurantium. Now in Citrus aurantium there is a sweet orange and there is a bitter orange. The sweet orange is Citrus sinensis, the bitter orange is generally referred to as your Citrus aurantium. They all belong to the family Rutaceae. Now if you see this orange peel carefully, or you might have seen it while consuming your fruit also, the outer part of orange peel is orange, whereas if you see the inner part of it, it is more whitish and more porous and little rough in nature, whereas the outer coating is more oleaginous in nature. So if you see your orange peel, you can divide it, I am just drawing it schematically, into two parts. Let me call this as a white part, let me call this as a orange part. So the orange part is generally called as flavido, okay, and the white part, because it's white, is called as albedo. Now there is a little difference between the two. So if you see the flavido part, that is the one which gives the flavor. So in culinary industries they use the outer part, they kind of grate it and they call it as orange zest or lime zest. The reason being, in that outer part of the peel you have numerous oil glands secreting volatile oil. So the volatile oil containing glands, the pigment storing organelles are all located in the outermost layer called as flavido. Whereas if you see albedo, it's the lower whitish part. If you happen to consume orange peel at any time, you know that this whitish part is little bitter to taste and it contains compounds called as flavonoids. It contains pectins, it contains your cellulose and hemicellulose. So the white part is rich in more of fibrous derivatives, whereas if you see the flavido part, it is definitely cellulosic, but along with that cellulose are embedded numerous glands containing your essential oils and also containing the pigments which are present in the oranges. So oranges grows mostly tropically and in the temperate region. So you will find them growing in India, China, you will see Spain, Madeira, Sicily or Morocco. They are the chief producers, but more than less you will find oranges growing everywhere in your tropical or temperate region. So it's a tree, and from this the pulp is taken for juice, for food, and what is thrown out is the peel. And like I said, the peel is more medicinal. So these peels are either removed in form of turnings or in form of gratings, or they are chopped off as tiny squares and dried to get what is called as dried orange peel. Much of this dried orange peel goes into extraction of orange oil or citrus oil, which is used in your perfume industry, and what is left back is rich in your pectin and flavonoids. So you get your pectin and flavonoids from the orange peel from which the oil is already removed. So while removing the orange peel, some might have experienced that there's a splurt of oil coming out as you bend the peel. So during the processing, care has to be taken that we don't do it so that the oil is retained and you can extract more and more oil from it. In order to prevent the evaporation of oil, it is always stored and dried in a shade. Now what does this contain? So focusing on our flavonoid derivatives, the chief flavonoid which is present in orange is hesperidin. Now different citrus varieties or different orange varieties give you different yield of hesperidin, but if you go to see all in all, you might come across an approximate of 1 to 2.5% of hesperidin. Now if you see the structure of hesperidin, this is your rhamnose, this is your glucose, and this is the main flavonoid derivative. Now carefully, if you observe this flavonoid derivative, it is a flavanone. Flavanone, why? Because this is a saturated, it is not an unsaturated. So this is a reduced part, there is no double bond here. So as a result, this is a flavanone derivative, and towards your 5 and 7, it's an hydroxy. If you remember in the previous session, while doing the biosynthesis, we saw that chiefly in most of the flavonoids you will find substitution at 5, 7, 3 dash and 4 dash. So same applies here, you have hydroxy at 5. The 7 hydroxy is what is involved in the glucoside formation, and here you have hydroxy at 3 dash and a methoxy at 4 dash. So this is the main flavonoid. Apart from that, you have your isohesperidin, you have your naringin. Now naringin differs in a way that I am just drawing the B ring. So you will have just a hydroxy located at a 4 dash position, remaining all remains the same. So that's your naringin. The aglycone of that is your naringenin. Now the next flavonoid what you have is your diosmin. Now diosmin is slightly different. Diosmin is not a flava, diosmin is a flavo. That means when I am going to do diosmin, I kind of create a double bond here. Now it becomes a flavonoid. So this, when the double bond is there, I will call it as diosmin. So you have your diosmin and a glycone diosmetin. Apart from that, you have what are called as polymethoxylated flavones. Now what are polymethoxylated flavones? Now just for your reference, I am drawing, this is your ring A. I am drawing your ring A here. In polymethoxylated flavones, what happens is instead of hydroxy, you get a CH3. In polymethoxylated, sometimes numerous substitution happens and you get lot of derivatives with lot of other CH3 derivatives also. So you have your nobiletin, tangeritin, which have a polymethoxylated A moiety being there. Now apart from that, this is the main flavonoid component. You will also have essential oil. The essential oil contains almost 90% pure hydrocarbon compound called as limonin, and that is responsible for a beautiful aroma. A little sweet note comes because of aldehydes such as citral and citronellal. So it has limonin, citral, citronellal as their major components. These are very effective in their cleansing action, and as a result you will find numerous of detergent bars using limonin as a aroma agent as well as a cleansing agent. Apart from that, it's rich in vitamin C and also rich in carbohydrate pectin. So industrially, much of your pectin is obtained from your citrus peels. Where do you apply all this? So because of the presence of flavonoids, you will see many of this citrus peel, or like both bitter, sweet, orange peel, they all exhibit anti-inflammatory activity. Now this anti-inflammatory activity is also exhibited on the endothelial cells, or that are what are called as vascular cells. So you see that patients suffering from chronic venous insufficiency. So what happens is my veins are no longer able to hold tightly, and as a result they turn soft. The cells are not very strong in their binding, and as a result the fluids tend to retain and seep out. All in all, these patients have swollen extremities, especially the swollen limbs, because of the drainage of water that happens to them. Now to treat this chronic venous insufficiency, one also additional case of chronic venous insufficiency is when you develop your varicose veins. So to treat this chronic venous insufficiency, what is done is your flavonoid derivatives, especially your flavonoid glycosides, are taken. Now this flavonoid glycosides are good, they are anti-inflammatory, they help in blood circulation, they help in endothelial health cell of especially of those cells which are there in the veins, and as a result they impart rigidity, they impart structure, and they kind of treat your varicose veins. So if you might have seen a tablet in market called as Daflon. Daflon contains almost 9 it's like a 450 is 250. So 450 parts is your diosmin and 50 part is your hesperidin. So these two glycosides which are present in orange peel are given in form of Daflon or in form of these tablets as a 500 mg tablets to treat varicose veins or chronic venous insufficiency. Now apart from that, your pectin which is obtained and the flavonoids, especially the polyphenolic compounds which are obtained from your orange peel, render a good antibacterial, antifungal effect. Even to certain cases, orange oil has been proven to show antimicrobial effect. The pectin present in it acts as a form of a soluble fiber and retards absorption of sugars and lipids by forming a thick mucilaginous substance in your gut. Now because of this, it's good for patients suffering from hypercholesteremia. So it acts as an anti-hypercholesteremic agent. It also helps you decrease your blood glucose levels. Now because of limonin, because of the oil, and because of its antimicrobial activity, as well as the presence of cellulose also makes it a good exfoliant. So this is the reason you will see your orange peel powder being there in your numerous products, orange peel extracts being there in your numerous products. Now diosmin, we have seen diosmetin, which is the erglycone of diosmin, is also reported and studied, and it is found to exhibit numerous activities because of its structure. This include anti-cancer, antimicrobial, antioxidant, estrogenic, as well as anti-inflammatory. So next time you are consuming the orange, please see that you consume the peel too. Okay. So with this we move on to the next set of compound, and the next compound is called as buckwheat, often referred to as kuttu ka atta. We see in market nowadays your buckwheat noodles, your buckwheat flour. Now what is buckwheat? Buckwheat is made up of two common species of buckwheat that are there in market. One is the Phagopyrum esculentum, the common one, and then there is a Tartary buckwheat which is Phagopyrum tartaricum. Now both of them belong to the Polygonaceae family. They are not clearly Graminaceae. They have a slight different appearance, but all in all the plant cycle is almost similar to them, like a 90-day cycle. Now they are commonly grown in China, Russia, Brazil, Poland and France. So if you see, as opposed to your other grains, the buckwheat kernel is slightly more, like a heart shape or triangular, and it's almost little big, like half a centimeter to a centimeter, that is 4 to 9 mm in length. Now this buckwheat contains flavonoids. Now this flavonoid is your rutin. As hesperidin, you have seen the substitution of the sugar was generally here. In rutin, the substitution happens at the third position. So again you have your rhamnose here, you have your glucose here. Now instead of a methoxy, you have a dihydroxy substitution at 3 4 and a hydroxy substitution at 5 and 7. So flavonoids are very easy to recollect because most of the times you will find a very similar or close substitution here. Now this is the main one. If you remove the sugar part of it and convert it into an glycone, this is called as quercetin. So quercetin is the glycone of your rutin. Apart from that, it also contains your flavonoid glycone called as kaempferol. It has lutein, vitexin, orientin and other metabolites of quercetin. Apart from that, being a grain, it is rich in polysaccharides, proteins and fatty acids. In fact, it is one of the drug which is said to be gluten free. So if you eat kuttu or if you eat buckwheat flour, it is considered as a gluten free alternative for people having gluten intolerance. It is rich in vitamins and also contains to certain extent triterpenoidal saponins. It also contains one more interesting set of compounds called as phagopyrins. Now what are phagopyrins? Phagopyrins, if you see, are actually compounds which resemble to your senosides. Now what is the resemblance point? The resemblance point is a dianthron moiety. But if you remember, in your senna, the linkage was only this point. So if you see your phagopyrin, especially the photophagopyrins, you will see a double linkages out here. Now this photophagopyrins, in presence of sunlight, undergo what is called as oxidative coupling and as a result become or get converted into phagopyrins. So if you can see, an additional bond is formed out here. Mostly in this substitutions you will find heterocyclic nitrogen containing rings or other substitutions being attached. So the substitutions are add-on, but just see the core part of it. So this reaction, now you can see, is a very resonance stabilized structure. So this structure, that is phagopyrin, have the ability to act like photosensitizers. Now what are photosensitizers? Photosensitizers are the molecules, so if we consume them and then we come in presence of light, so photophagopirin will get converted into phagopyrin. Phagopyrin will absorb light and start emit fluorescence or start emitting radiation at a little higher wavelength. Now because it starts emitting radiation at a little higher wavelength, what happens is they give rise to what is called as phototoxicity. Now this phototoxicity can be something like a just mild itching, or in some cases it can give you sunburn or like a very fuzzy feeling or intense itching. So this is again predominantly observed in animals, especially the white or the albino animals which graze on this phagopyrum. The reason being, more than the grains, this phagopyrin or your photophagopyrins are found in the leaves as well as the inflorescence, especially the flowers. So if you consume that, the chances of you getting the phototoxicity are much higher as compared to grains, where these are like minimal to almost non-existent. Now comparatively, if you see your common buckwheat is to your Tartary buckwheat, the amount of flavonoids is much higher in your Tartary buckwheat. So where do you use this? So this buckwheat has nowadays become common food because, like I said, it's rich in minerals, it's rich in flavonoids which have a good antioxidant potential, and as a result it is known to give you a lot of good effects, especially like we just saw previously, vitamin P like effects. So rutin, being very closed or allied in structure to hesperidin, also possesses a very similar kind of attributes. So it improves your blood vessel health, it improves your vascularity, it improves the strength, and as a result it will help you in your venous insufficiency. Rutin and quercetin, being polyphenolic in nature, will also show you antioxidant effect, and as a result they have anti-tumor, anti-mutagenic, cardioprotective, and to some extent immunomodulatory effect. Now this is one of the grain, like I said, it's not clearly graminase, so it contains to little extent improved blood sugar control, and as a result it's used in numerous places. This includes your gluten free food, buckwheat noodles which are there in market nowadays. It's also used as a grain for preparing alcoholic beverages, preparing something like your buckwheat honey, which is made up of fermenting buckwheat, and your sauces. Now we move on to the next drug. The next drug is not a drug, actually it's a fruit that you consume in almost during the winter season. You will see a lot of this occurring in market here, and this is your simple common strawberry. So why is strawberry medicinal, or why is strawberry good, and why are we studying it here? So let's discuss strawberry in detail. So this is your common strawberry, also known as your Fragaria ananassa. Okay. Now it's actually the one which we consume in market, it's a hybrid. So whenever you see a notation like this, it indicates that the plant is a hybrid species. So it's a hybrid obtained from two wild species, Fragaria chiloensis and Fragaria virginia. They belong to the Rosaceae family member. Now this fruit actually is a pseudocarp. That means the fruit, as you see, is not a fruit. What is there is, so what you see in a red color is the receptacle of the flower, whereas you see something like this tiny seeds. This tiny seeds or acnes or seed like acnes are actually the fruits which are there on the surface. So it's not a true berry, it's a pseudocarp. This is not a fruit, this is what you call it as swollen receptacle, and this tiny seed like things are the fruit which is there in the strawberry. So this strawberry is made up of beautiful pigments. In fact, people are advised to take pigmented foods for the reason. Let's discuss here. So strawberries contain mostly water. The sour taste is attributed to presence of acids including ascorbic acid, and it contains pigments which are intensely red in color, and because of acidic pH you will see them more red. The pigments which strawberry contains is your pelargonidin, especially pelargonidin 3O glucoside. So at the third position of this anthocyanin, you can clearly see it's an anthocyanin. Why? Because the flavinium ion is there. So because of the flavinium ion, the oxygen carries a charge and it gives rise to typical red coloration as opposed to a little pale yellow of flavonoids. It also contains little bit of cyanidin 3 glucoside. So both of these pigments account for the red coloration of strawberry. Now more is the sunlight, more is the amount of pigment that this plant is going to produce. We know that the flavonoids derivative are produced in response to stress, in response to UV. So more UV you will receive, the more pigment you will kind of get. Now interesting part of this anthocyanin derivatives is anthocyanins act as pH indicators. So if you see this carefully, this is acidic pH, what happens, and as you go towards more neutral pH, you will get what is called as quinoid formation. So what happens is this will go, this will kind of stabilize and you might get a quinoid formation here. This quinoid formation later on in alkaline pH leads to what is called as the ring C cleavage, and as a result a lot of color changes happen, and that's the reason anthocyanins are natural pH indicators as well. So at acidic pH you have the flavulum ion, at neutral pH you have a little quinoid moiety minus this, and at near alkaline pH, if you keep it for a longer duration of time, you will see that the C ring will open up. Not only that, the coloration of anthocyanin pigments also depends on the nature of substitution. So what you see here is a single hydroxy. Okay. Now in this case, if I make it triple hydroxy, instead of pelargonidin you get derivatives like your delphinidin. Okay. Now delphinidin is more intense red to pink in color. Now I can have this OH being substituted by CH3. So I'll get like peonidin and malvidin. So peonidin and malvidin are more bluish purplish color pigments. So going from single hydroxy which is red to more hydroxy substitutions which are more pink to methoxy substitutions which are more blue to purple. So depending upon what is been there on this typical ring B, you can get different colors. Depending upon the pH also you will get different colors of your pigments. So that is why your anthocyanins are very important as well as interesting. Apart from that, it also contains a flavonoid derivative, especially a flavonol derivative, and that's your fisetin. Fisetin is one of a very important supplement that is there in the market nowadays, which is also used as an anti-aging supplement. You will have your quercetin, camphorol, ellagitannins and other phenolic acids which are also been present. Now let's see uses. So what advantages do I get when I consume strawberry? Definitely you have advantages of consuming acids, phenolic acids. You have advantages of consuming your vitamin C, so you have anti-inflammatory, and depending upon anthocyanins and flavonoids which are also polyphenolic and antioxidant in nature, you get numerous advantages. So it has been reported to support your brain health, heart health and also in cancer prevention. Now the reason fisetin is becoming more popular in market nowadays is it has antioxidant, anti-inflammatory effect, but it has what is called as senolytic. Now senolytic is the ability to kill what are called as zombie cells. So remember, you have aging cells, and aging cells have a phenomenon called as apoptosis. So they should naturally die, but in some cases these cells just sustain. So that leads to what are called as age related disorders or aging disorders. So imagine if somehow you are able to cause apoptosis in such cells and get rid of the cells. This is how senolytic agent work. So wherein the apoptosis process is stalled, it's not working properly, senolytic do their way of clearing the cells. They kind of re-emphasize on this mechanism and get rid of the aged cells. As a result, leaving scope for the new cells to grow and divide and more healthy generation of newer cells, especially your brain cells, especially your skin, and as a result that's where your senolytic agents feature in. Nowadays senolytic agents have also been studied for cancer prevention. So with this we discussed 3 drugs today. We had your buckwheat, we had your orange, and we had your strawberries. So, if you wish to read more about it, here are few references. And thank you everyone for your patient listening.